This video explains the tests conducted as per IS 1161-2014 for steel tubes for structural purposes, an Indian standard developed by the Steel Tubes, Pipes and Fitting Sectional Committee (MTD 19) under the Metallurgical Engineering Department at BIS. Before performing the tests, please make sure you comply with the safety practices in your lab and also the ones required for the tests specified in this video. Today, we are going to explore something that plays a silent but significant role in the buildings, bridges, and structures we see around us every day. Have you ever wondered what makes these structures so strong and durable? One of the answers lies in the steel tubes used for structural purposes. Have you seen scaffolding at construction sites or the framework of a sports stadium? Steel tubes are used in these structures because of their ability to handle stress and their ease of assembly. Steel tubes are cylindrical, hollow sections made of high quality steel. They are designed to provide strength, durability, and versatility to structures. These are widely used in construction, engineering, and manufacturing because of their excellent properties. The Bureau of Indian Standards has developed a specific standard for such tubes, that is IS 1161-2014, which ensures their quality and performance. The term designation refers to how steel tubes are identified based on certain characteristics. This helps us understand what type of tube is suitable for a specific purpose. Steel tubes are designated by their nominal bore, which is the internal diameter of the tube, and by the thickness of their walls. The tubes are classified into different grades based on their yield strength, that is, the amount of stress they can handle without deforming. The grades mentioned in IS 1161-2014 are YST 210, YST 240, YST 310 and YST 355. A complete designation includes both the nominal bore and the grade of the material. For instance, a tube might be designated as 50 NB YST 310, which means it has a 50 mm nominal bore and has minimum yield strength of 310 megapascal for that grade. Now, let's get a bit more specific. What does the 240 in the grade YST 240 represent for steel tubes? It represents that the minimum yield strength for the grade YST 240 should be 240 megapascal. Clause 5 of IS 1161 focuses on the chemical composition of steel used in both seamless and welded hollow sections, ensuring the material's strength, weldability, and overall performance. For seamless sections, particular attention is given to impurities like sulfur and phosphorus, which are strictly controlled. For welded sections, the chemical requirements are extended to cover a broader range of elements as per IS 10748 and IS 2062 guidelines. Seamless hollow sections are produced from steel manufactured through approved metallurgical processes. The chemical composition is carefully controlled to ensure high material performance, particularly with respect to sulfur and phosphorus content, as these elements can influence strength and ductility. The limits for seamless sections are sulfur, which is maximum 0.040%, and phosphorus, which is maximum 0.040%. These limits help reduce brittleness and improve ductility, enabling seamless sections to endure high stress and dynamic loads effectively. Welded hollow sections are made from hot-rolled steel strips that comply with IS 10748 or IS 2062. The chemical composition of these sections is designated to maintain good weldability and structural integrity. The key parameters for welded sections include carbon, which is maximum 0.23%, manganese, which is maximum 1.70%, sulfur, which is maximum 0.045%, phosphorus, which is maximum 0.045%, silicon, which is maximum 0.50%, and nitrogen, which is maximum 0.012%. Microalloying elements like niobium, vanadium, and titanium may be added to enhance the steel properties, but the total of these elements must not exceed 0.20%. Copper bearing steel with copper content between 0.17% and 0.38% can also be used for weather-resistant applications based on an agreement between the manufacturer and the purchaser. Additionally, alloying elements like chromium, nickel, molybdenum, and boron can be added by the agreement, and their quantities are as regulated. For example, chromium should be less than or equal to 0.50%, nickel, which should be less than or equal to 0.60% for specific grades. The chemical composition of steel is crucial for its performance in hollow sections. Strict control over elements like sulfur and phosphorus help prevent brittleness, while elements like manganese enhance toughness and ductility. The addition of microalloying elements improves strength and grain structure, all while maintaining weldability. For welded sections, controlling nitrogen content is essential to avoid cracking during welding. The chemical composition of steel can be verified through ladle analysis. As specified in IS 228 or through advanced techniques like spark optical emission spectroscopy, that is SPARCOES. It is particularly favored due to its ability to analyze multiple elements simultaneously with high precision. SPARCOES works by generating a high-energy spark between the sample and the electrode, vaporizing a small part of the material to form plasma. The light emitted by this plasma is analyzed to determine the elements present in the sample. For accuracy, certified reference materials, that is CRMs, are used to calibrate the SPARCOES machine, ensuring consistent and reliable results. Once the chemical composition is determined, the results are compared with the requirements specified in the relevant standards. These results are then recorded and reported using LIMS software, providing a detailed record of the chemical parameters for quality assurance and compliance. Let us dive into some interesting facts in the form of question and answers. What is the maximum allowable sulfur and phosphorus content in the seamless hollow tubes as per IS 1161? The maximum allowable content is 0.040% for sulfur and 0.040% for phosphorus. What type of equipment is essential for sample preparation in SPARCOES analysis? A sample polishing machine is essential for preparing a smooth, even surface for accurate results in SPARCOES analysis. Clause 6 of IS 1161-2014 details the standard sizes and masses for steel tubes for structural purposes. Understanding these specifications is crucial for engineers and builders to ensure safety and structural integrity. The standard sizes and masses of tubes for structural purposes are provided in Table 1. It is important to note that thicknesses below those specified in Table 1 are not permitted, while thicknesses exceeding those in Table 1 are allowed if agreed upon by the purchaser and the manufacturer. Other parameters like area of cross-section, moment of inertia, modulus of section, radius of gyration, etc. are also mentioned in Table 1. However, these are not mandatory requirements and given just for information. To calculate the mass per unit length, measure the length using a vernier caliper or steel scale. Determine the mass using a weighing balance. Calculate the mass per unit length by dividing the measured mass by the measured length. Dimensional parameters like thickness, outside diameter are measured using micrometer or vernier calipers. The tolerances on these measurements will be as per clause 6.2 of IS 1161. Workmanship in steel tubes as per clause 7 of IS 1161 2014 ensures the tubes are safe, strong and reliable. The tubes must be cleanly finished, free from cracks, surface flaws and defects. Their ends should be cut neatly and squarely to fit perfectly into structures, while minor surface imperfections like handling marks or shallow pits are acceptable if they don't weaken the tube. Welded tubes must have smooth, protrusion-free seams. Good workmanship guarantees that these tubes perform well under pressure, seamlessly into structure and last longer, making them essential for safe and sustainable construction. Have you ever noticed that metal objects left outside sometimes get rusty? Rust weakens metal and makes it less durable. That's why we use galvanizing, a process that makes metal a protective shield. According to clause 8 of IS 1161 2014, if steel tubes need extra protection, they are galvanized. The galvanizing process follows strict rules under IS 4736, ensuring the zinc coating is even, strong and sticks well to the tube. Let's talk about an important quality of steel tubes called straightness. Imagine trying to build a bridge or a swing with bent or wobbly tubes. It would not be strong or safe, right? That's why clause 9 of IS 1161 2014 makes sure that steel tubes stay straight and true. Straightness means the tubes should not be bent or curved too much. According to the standard, a tube can only deviate by 1 mm for every 600 mm of its length. That's like saying a ruler should be almost perfectly straight, even over a longer distance. This ensures that the tubes fit together perfectly, making the entire structure stable and reliable. For measuring straightness, place the hollow section on a horizontal surface with one side at one end pressed flat against the surface. At the opposite end of the hollow section, determine the difference V in the height of the two lower corners from a horizontal surface using feeler gauges. Steel tubes are usually supplied in random lengths between 4 to 7 meters, which gives flexibility for different uses, but sometimes exact lengths are needed for specific projects. In such cases, the manufacturer and the purchaser must agree on the precise measurements and tolerances. This ensures that the tubes fit perfectly in the structures like bridges, buildings, and even playgrounds, making them strong and reliable. Tensile tests are conducted to assess material strength, elasticity, ductility, yield strength, and suitability for applications. They help determine a material's behavior under stress, ensuring it meets quality standards and performance requirements. This information is essential for material selection, design, and regulatory compliance. Here's the step-by-step process. Start by preparing a sample from the hollow tube, ensuring it meets the dimensions specified in the standard. Secure the sample in the UTM using the appropriate grips, making sure it's tightly fastened. Enter the test parameters into the software, including the gauge length and cross-sectional area. Then initiate the test by starting the machine. As the load increases, the sample will eventually break under stress, and the software will automatically display the tensile strength of the sample. The requirement of the tensile strength for various grades is as per Table 2 of IS 1161. Which test is mentioned in IS 1161 that assesses the material strength and elasticity. That's the tensile strength mentioned at clause 11.2 of IS 1161. On which machine is tensile strength test conducted? The tensile test is conducted on a universal testing machine, that is UTM. Let's explore an interesting quality of steel tubes called ductility. Imagine bending a metal rod to make a curved shape. If it bends without breaking, it's ductile. Clause 11.3.1 of IS 1161-2014 ensures that steel tubes used in structures are ductile and can handle bending or flattening without cracking. For small tubes up to 50 mm in size, there is a cold bend test as per IS 2329. In this test, the tube is bent 180 degrees around a curved tool, like folding a paper in half. It must bend without cracking at the weld or surface. To carry out the test, take the sample and bend it around a groove having radius 6 times the outside diameter of the sample. After the test, the tube shall not show any crack. For which dimensions of steel tubes does ductility test is applicable? Ductility test is applicable for larger tubes below and up to 50 mm in size. According to which Indian standard ductility or cold bend test is carried out? The cold bend test is carried out as per IS 2329. Now let's dive into the flattening test, an important part of making sure steel tubes are strong and safe to use. Imagine a tube in a bridge or a building. It must be tough enough to handle heavy loads without breaking, right? That's what the flattening test checks. This test is for larger tubes above 50 mm in size, is carried out as per IS 2328. A ring is cut from the tube and placed between two flat plates. These plates press the ring until it flattens. No opening shall occur by fracture in the weld until the distance between the plates is less than the value specified for each grade in column 4 of table 4, and no cracks or breaks in the metal elsewhere than in the weld shall occur until the distance between the plates is less than the value specified for each grade in column 5 of table 4. This test proves the tube can handle being squished or pressed in real-life situations, like during construction or under heavy loads. By passing the flattening test, steel tubes show they are ready to be part of strong and reliable structures. For which dimensions of steel tubes does flattening test is applicable? Flattening test is applicable for larger tubes above 50 mm in size. According to which Indian standard flattening test is carried out? The test is carried out as per IS 2328, and that brings to the end of our journey through IS 1161-2014, the standard that ensures steel tubes are strong, safe and reliable for all kinds of structures, from quality workmanship to precise dimensions, protecting galvanizing and rigorous testing. Every clause in this standard plays a crucial role in building a better and a safer world. Remember, standards like IS 1161 are more than just guidelines. They are the foundation of trust and safety in the things we see and use every day. Thank you for watching, and let's continue to build a future where quality and safety always comes first.